industrial control system security. First, a small disclaimer. I know that this is a very broad area, and I'm not going to discuss everything from this area, or at least the reasonable part of it. I'm trying just to go into some examples of what can be done, and to give some reasoning what happened so far. So, is it really so loud? This sounds extremely loud on my side. Okay, so industrial control systems, they have been discussed for ages now. We have now 30 years of industrial control systems. They are kind of everywhere. They control public transportation, energy systems, and so on and so forth. And I think Eric Iris of Sofia Security, he kind of described it quite good by saying that with the uprising of the Stuxnet, that was the first time that people really get aware of how important, how dependent we are on industrial control systems. Some people, like Joseph Weiss or other people, looked at that before, but with Stuxnet, this was the first time that people really looked at the stuff, at this data system, at the process control systems. And interestingly enough, nowadays most people have feared of the existence of industrial control systems. But most people are not really aware of what are the challenges in this area, because we are all aware of how a PC environment works, how an office environment works, how governmental environment works, but industrial control systems are kind of different. For example, this maintenance window I have in an industrial control system. I know a lot of systems that have 4 minutes in a year. 4 minutes downtime a year. So that means I have 4 minutes to shut off, to do updates, to get it out of the system, put a new box in there, or whatever. Then I have to be off again. 4 minutes. That's quite little. We were discussing here before the not so rare updates of mobile phones, and I think we are spending much more time a year on software updates for a smartphone than 4 minutes. Then we are kind of dependent on software updates. Industrial control systems don't know software updates in most cases, or in many cases. I know systems that are running since 10, 15 years without any software update. The basic reasoning behind this, in some areas, the software has been certified for safety reasons. In the oil industry, for example, you don't go through the hassle of evaluating and recertifying the software without a functional need. The same is true again for the availability and runtime of the systems. Well, 4 minutes a year downtime or 99 point whatever percent of availability. That's the aim. The productivity of the system is the most important thing. I can't stress that point enough. Availability is the real cornerstone of the whole industry. It needs to be functional, it needs to be productive, and if it breaks down, well, in many cases you can throw away the whole production line or even the machinery. That all comes down to a nice thing. You don't shut off industrial systems. You just don't do it. Think about a chemical plant that mixes some components. If you get it wrong, if you put the wrong amount of chemicals together, it is kind of dangerous. We have some examples there. You just don't shut them off even if you know they're compromised. You don't do that. If you can circumvent shutting them off, you do. If you know it is just spamming the world, you don't shut it off. You wait for your maintenance window. In the worst case, after a year. And another thing that is very different from normal PC systems is that we don't have a user in front of the system. think of an oil rig or something like that. There's not a person sitting in front of the device that controls the drill. There's somebody, the guy supervising them somewhere else. You don't have a person directly controlling it. They're kind of somewhere deployed, but not checked by the person. Something like that. Which is really, really different to normal PCs that we are used to. I know that there are a lot of other differences in terms of hardware and whatever. We had it before, like Lisa told us that we can't expect, even in PC environments, everywhere the same operating system, we can't expect that the operating system is on the new solution and so on and so forth, but that is kind of what we have seen everywhere. It's a bit tougher in the industrial control sector, but kind of comparable. As I said, I'm aware that it's not everything, but it kind of points out the nice things that we have, especially if you go, you see a lot of more requirements from the industrial systems if you go to special application areas. For example, if you go into avionics, aircraft, large aircraft examples, you meet other issues coming, for example, from certification. For example, the typical issue that you have in certification of devices, that all devices need to be absolutely identical, which sounds in the first approach not so complicated, but if you think from a computer perspective, it means that you can't deploy a key that is different from another device. All devices deployed need to have the same key material, because the DO requirement is all devices need to be 100% identical and they're being so planned as a direction. It's kind of a hard issue that you have to work with, for example. But these are special requirements for very, very different use cases. You can't lose them. It's just too much. By the way, if there are any questions, or well, I'm not a native speaker, so if please tell me. Don't interrupt me. Again, generic virus. Well, of course, Topino is part of the classical group. I think I like this program because there is an insight to all the process systems that we have. We are totally dependent on it. As companies, I would say systems like Windows, Linux, and iOS. They have more complicated, more sophisticated, and dealing with issues. And the industrial control sector is kind of slower in adopting any kind of security at all, because they have, from a traditional view, the so-called air gap. They assume that if my production system is not attached to the internet, I'm fine. If you look a bit more closely to not attached to the internet, you find an average 15 ways to get data from the internet into a production system. In average. There are, for example, the maintenance laptops being moved from the office of the guy or the maintenance guy to the production side, USB sticks, other media, of course, the communication to a back office that controls the production side. We saw, for example, one really nice example of a really sophisticated Excel spreadsheet. You could type in a number, and magically somehow the production changed the amount of oil consumption. That was really sophisticated spreadsheet with a lot of visual basic magic in there. Really cool. But still, the systems have grown. They're quite complex and not well understood in terms of security and interaction between back office, production side, and so on. And then you get also problems with, let's call it, old equipment, old software that's well-known parts. So what could happen if we have a cyber attack in our industrial control network? Well, we're kind of, I think everybody here is quite full of ideas. I just like to highlight three possibilities. I think that is one thing that most companies are kind of threatened by is, of course, data leakage. Because for my industrial control systems, I can derive a lot of insights on the production secrets. I can figure out what chemicals are mixed in what quantities. For example, I can figure out what production processes and so on. I don't need to have the formulas they're using, but I can look at the production. As that is open, I know everything they know, which is quite nice for the attacker. Then, of course, this orders of the production processes. Well, if I have an attacker in my system, he can change the production or try to destroy my equipment. Well, Stuxnet still, that is for some parties the name to do that. And of course, damage of equipment or product. Well, I have something in mind that I produce some medication, something without any useful ingredients anymore. What left out of the list is, of course, damage to people. I mean, people coming from the control side of robots, for example, fast-moving robots, they have kind of a security measure that they don't move while somebody is moving within their range, which is a sensor attached to a IP network, signaling the control system should stop. Well, I think everybody gets the notion there, what we can do. And we are back in the 1980s where Toyota employees were killed by robots. So, I think we know all about, I think with that is that we have now a basic understanding about what is an industrial control system. Very rough, very basic, but still it gives an idea. So that is a trusted computing conference. The question now is, what can we do with trusted computing to help you? How many people are aware of what a TPM exactly is and what we can do with that one? Okay, not everyone. So a lot of them are suffering, others are seeing something new. Trusted computing, we have the word trust in there. The trusted computing group has a quite nice phrasing that can be trusted, it always behaves in an expected manner for its intended purpose. That is how trust computing group defines trust. I have more down-to-earth example. If I'm in a city, it's dark, and I meet somebody who looks like a murderer, I have perfect trust in this guy that he will murder me. Do I like the outcome? Definitely not. Do I trust him in that? Yes, I do. It's important to keep that in mind because we're not discussing here trust in a way how humans define trust. Because I'm here, I'm trusting you, I don't know why that you don't kill me. But that is a human way to define trust. In the world of machines, we can just say I'm trusting something if it behaves in a certain way, or I expect it to behave if I like the outcome or not. That is not relevant to the definition. There's no goodness in this definition. So that is important to keep in mind because what we do with the trusted computing group, we provide technology to determine the behavior of the device. We don't say that the device does what we think it's doing, or what we hope it's doing, but that the outcome is good. Well, second thing, we have to differentiate between the tamper-proof and tamper-evident device. A tamper-proof device is quite costly to build, if it is even possible. I would say if it is tamper-proof, it is something turned off in a big block of concrete down at the ocean. I think that would be quite tamper-proof. Tamper-evidence, in contrast, says the device could be changed, could be malicious, but we have a way to determine if that device can be trusted as healthy, or whatever we like to say, and that we can communicate that behavior to another entity. And of course, in many scenarios, it is absolutely sufficient to have a tamper evidence. Well, if you like to communicate with somebody, they can show, they can give a proof of tamper. That is, I think, the most relevant use case, especially if you go back to the presentation before of Lisa in the area of network of combination of the also the communication and interaction there. And well, documentation is something else. So what do we offer with trusted computing? Basically, we offer a way to measure the platform. That means that we do in practical, we do make hash values of the software before it is booted and before it is started. So we calculate the hash value of every software before it is loaded into the RAM. Then we provide an attestation process. That means we can provide proof on the measurement to the external entity. So basically what we can show is that we are healthy if we provide all the infrastructure equipment for that. And the third thing that we can provide with trusted computing is the protection of keys and other material. So we can make sure that a key or certain block of data can only be decrypted on a certain device in a certain state. How do we do that? First, we define a couple of roots of trust. Basically, we have a root of trust measurement that makes sure that we can measure the device. This is a platform functionality. We have a root of trust for reporting. This root of trust for reporting is basically our TPM. It is a responsibility that is responsible to answer questions from the outside, saying, what software was loaded, have you seen that? And we have a root of trust for storage that allows us to protect keys. What we then have, using these three roots of trust, we can build the trusted root process. That means we start with the root of trust measurement, which is nowadays mostly implemented as part of the BIOS or UEFI, which measures the real BIOS or UEFI that comes afterwards. And before it starts, it reports back the hash value to the trusted module. As soon as the BIOS or whatever entity there is in control, it makes sure to hash the option ROMs, the microcontroller updates to the processor, and of course, the OS loader hashes them before it executes them, reports them back to the trusted platform module, and of course, into a list of measurements, the stored measurement log. Therefore, we now have a list of every component that is started of the system, and we know due to the fact that we build it that way, that it was always measured before starting, that if we have a malicious piece of software, we can see it in the list because it is different from its hash value as it should be. For the people who read a bit about trust computing, there's always the notion that this trust is transitive. Well, it is. Because no component stops the boot process. It just runs through and we have an indication that something is different from the reference, but we don't stop. We don't make activities. The trust component doesn't stop the boot process or any kind of software execution. So there's nothing where we can put our trust in terms of, let's say, enforcement. We only have a reporting process. That builds, at the end, the so-called chain of trust. And we have the root of trust measurement starting, and all the components then continuing with the measurement process. The We have 15 of them, so we can build a platform design that fits sometimes the needs of modularity, so that we can have one platform configuration register for the BIOS, for the data, for the OS loader, for whatever you like to have. Especially there is a standardization for that, how to use it in the PC client platform. But if you're going for specialized equipment, for embedded equipment, there's no specification so far, and that needs them to be adjusted. We did that in several projects before. It's always kind of interesting to see how a specific device works and what needs to be measured and how this chain needs to be built to fit the requirements of software updates, of all the changes that can happen to a boot and still have a usable measurement system. So, to get to that there, what do we do? We need to show to an external party the measurements, because that's the part where we start the security evaluation. Up to now, we just measured the device. With the remote attestation, we provide the trusted boot we had before. Trusted boot is different to a secure boot. Please keep that in mind. There's a lot of discussion going on at the moment. And we have the attestation process. That means we have these measurements. We have the TPM, and the TPM can show to an external partner that he saw the measurement. So it can say, this boot process happened in a certain way. How is documented here? And we can, as an external verifier, and say, okay, I have my list of measurements. The TPM vouches for this list of measurements. Is every measurement how I expected? If I check that, if I'm satisfied with every entry in my measurement list, that system is supposed to be in a good state or healthy. If there's a bug in the system that I define as healthy, well, I think that we need to have about 5 minutes a year to solve that one. Okay, so what can we do now? We have a bit of basics on trust continuous. Infrastructure protection. From my experience with a lot of this infrastructure there, we have some requirements. We need it to be as independent as possible, because the reaction needs to happen between devices, and in many cases I don't even have a centralized system to look at everything in the network. So I need to be able to provide kind of a distributed system to react to software incident and to security incidents. It would be nice if we can prevent the spread of malware infections as early as possible, because if it spreads, well, we do. So early containment would be one aim here. As we, in many cases, can't do anything really, because we have to maintain the availability of the production, we have to provide at least a fast warning system, and we also like to protect our confidential data in the system. And what we, in many cases, like to have also is the update process that is more secure than what we have, that we can make sure that the software that we deploy is really the software that we want to deploy, and have also message tags that we can rely on, that really the software that we wanted to have installed is really installed in the device. Kind of a maintenance requirement. So, Transport Group is already offering a lot of technologies in this area. We had the talk of Lisa before about Trust Network Connect and the IF9. I don't want to go into the big detail and the great detail there. Basically, Trust Network Connect allows you to have this as do an endpoint assessment. IFMAP allows you to automate security processes within the network, and to integrate different sources of information. Well, if you like to have details on that, I think the guys at Tulip are quite happy to just show up at the booth down there and ask them a lot of questions. They have a cool demo, as always, with them. So I think that's quite sufficient there. But just what you can offer a little more, even on things that are not really already available in terms of products. What you can do, and I show it in an example a bit later, is you can optimize the deployment process of software. And it also has the potential to enable some new business cases like secure top networks. We developed at our institute we call it the transfer market. That means so basically our goal there from the partner we had at that time is that we had a case of a lot of places like windmills that need to be connected. And why is it doing it automatically? So the challenge there was that we have this huge amount of pillars, so to say, and they needed to be connected. The idea was to use an network, but that was not really applicable because it's not equipped with any security functionality in there. But from the point of view of the operator there, the requirement was, I don't want to put the cable into the ground for every new pillar, which is kind of costly. They don't want to do that. So what we propose, I hate it when it does something automatically. So what we propose is that we can build a system where every node can check automatically all the neighbors. That means if one neighbor is compromised, we can automatically detect that and isolate it. So every node on its own can determine, do I like to talk with the external entity or not? Do I like to talk with my neighbor or not? I can then just shut down this one little part of communication. And react to that accordingly by notifying the central command and tell them, I found a node that is not in the state that I like. Please take care of it, and until you have taken care of it, I don't want to communicate with them. Yeah.
Is that functionality built into some part of TCP infrastructure, or do you have to write code to go through the process of finding out if the node's okay and then reporting it to something else?
I have a demo down there in our booth showing the functionality. It's completely built upon standards.
Right. So somebody wrote some code, or there's a third-party product that does this. Is that what you're saying?
Yeah.
Okay.
Well, we wrote the code.
Okay.
Basically, it allows you to react quite fast to a change in the system. If you change the neighbors all the time.
Yeah, something outside, it's creating TPMs on all the different nodes some way, and then responding. Yeah.
Basically.
Okay.
It's a bit more complicated, but basically that's the idea, to gain, say, every 20 seconds or whatever, the health status of the neighbors, check that with your reference value and say, you're good or you're not good.
And the peers are doing this with each other? Or
yeah.
Okay.
Independently, autonomous.
The peers are doing it, and then in your model, there's somebody to talk to.
Yep. Okay. Which is which kind of speeds up your reaction to an incident. If you do it autonomously, you don't need a centralized entity to do that for you. So what we can then achieve is we can report modifications, we can prevent the spreading, it's a spread also modification, and we can do a quite intelligent reaction to an attack. Well, having the reference values of software, we can differentiate between a healthy system, a system that is just an outdated version of software, a system with a known malicious modification and an unknown malicious modification, which gives us a kind of a degree of freedom to react to a certain incident. If I already know the maliciousness of the system because I saw it before, I typed it, I already have experience how to isolate that behavior, I can still get the stuff, let it operational, and that maybe can just isolate it on this network means or something like that, and come up later with a standard maintenance window and change it. I don't have to react immediately. In contrast to something I don't know anything about that time. Okay, another thing that we did is zero-touch configuration. Well, I know this term is quite kind of well used nowadays, but if you have a transfer platform module in your device, you can kind of address the typical deployment problem that you have, for example, with smart meters, which is a kind of usual use case there. Well, if your utility buys a smart meter, normally they buy a huge quantity, get them shipped to the headquarters, and there's a guy with a USB token individually configuring every device and shipping it back to the place that needs to be deployed. I was told that doubled the price of the device because of the shipment and the guy individually doing it. Well, what trust computing does, what GPM does, it hides a lot of the complexity of public key infrastructures. It hides all the hassle about security, using security by putting everything into one chip. So what you can do basically is assume where you can take your meter, ship it to the place where it needs to be deployed, turn it on, and let the TPM discuss with your headquarter the specifics of the deployment, of the configuration, and so on. You don't need to individually configure every device in a certain secure location in your headquarter or wherever. If you like to have details on that, please talk to me at the booth. That's going to be too deep for talk here. Just to get that picture complete here. What we can also do, of course, is we can provide for confidentiality. For example, a typical case, we had that a couple months ago, a company that builds machines to produce chicken, the small parts you can buy at a fast food restaurant. And they're selling these machines to China. And they're kind of afraid that they're selling one machine to China and China sells 10 back. Yeah. So, TPM offers the protection of credentials. That means we can also protect, say, the algorithms and so on. It's not so complicated to build. You just have to look at the specifics there or talk with us. And another thing is, of course, product counterfeit. It's a typical thing that companies are not building their equipment themselves, but outsource that to other countries or to other companies, and to make sure that only the amount of devices that you want to sell on the market, you need some techniques. You can also address that with the trusted platform module. Of course.
Are there any supply chain controls on TPMs? Are any of them built onshore, for instance, as far as you know, or any of that?
Supply chain.
In other words, we're worried about the Chinese getting
okay. At TPM, well,
Isn't the TPM started out in China?
Say it again, actually. Just say it again.
Just TPM supply chain, is there any attention to it?
Yeah.
Okay. Trusted sources,
yeah. The TPM, if it is compliant to the spec, is certified according to EL 4+. That's criteria EL 4+. That means it has a certain resilience against hardware attacks. You can't just open the chip and look into the details and get the keys out of it. And the vendor, for example, Infineon, already injects an identity into the chip together with a certificate saying this device is produced by Infineon, and you can be sure that that chip containing this key is a good TPM produced by us. So if you get that one, you can make sure that with a certificate and the interaction with the TPM that you have in fact the real TPM of Infineon or ST Micro in front of you, which would be then the anchor for your supply chain. Does that answer the question?
Yeah, I think in a way it did.
Okay. Digital evidence is kind of a research hobby of ours. It shows this maybe over your point. We see a lot of devices out there that are designed to create digital evidence. And these devices can be connected, for example, to networks and so on. And that means they're kind of vulnerable. Please be aware, I'm not a lawyer, so I may use the wrong wording here. That's a good idea. I'm using an arbitrary example. Please map that to any use case you may think is also appropriate. Speed cameras. The device is designed to produce digital evidence that is used against speed. So consider the case that I'm using my typical German car, and that I have a typical German issue that I'm a bit too fast. In the good old days, there was a camera with a hardware film that made a picture of me, and as it is, I'm always not very happy about that, and I'm going to complain at Kurt that I wasn't so fast. Can't be, my typical German car can't be so fast. What do you think would happen if there's a typical court and the typical judge and the typical technical expert? Well, I'm going to use there's a film, they can show that tempered with wonderful. Different example. Again, my typical German car on my way to work. And now I have purely digital pictures. What would happen at court? Do I find a technical expert who is 100% satisfied that the picture taken is really the picture? Yeah. Already a bit more complicated, but I guess it would still work because the box itself is sealed. But that never was true. You don't see these systems in the real life. What you see, and that's kind of cool, you see digital cameras that directly stream the pictures into the cloud, and out of this cloud, the police gets the pictures stating, I was fast. But keep in mind, that service here is offered by an independent company that gets its revenue on a certain percentage of the income they produce. So interest in changing the pictures, public infrastructure, cloud service. Do I find an expert witness that says this picture is absolutely not tampered with? Well, I'm a technical expert at court, and I wouldn't sign that. But what we can do camera. And the touch technology offers us a possibility to give proof on system configuration. Is the software, gives us proof on the software that was running, and provides an identity. So I can track down the picture to the machine and to the software configuration of the machine. At the end, that means I can later testify that this picture was not changed since the time it was created. I can show the time when it was taken, I can show the software used, and I can pinpoint the device. Would I sign that as a technical expert, as a witness? I think so. Well, it looks a bit easy to do that. Well, in fact, I'm afraid it's a bit more complicated to build infrastructure, but it is possible. We have demonstrated for that. That was my short tour through possibilities we can do with trusted computing. I'm aware that there are much more possibilities, but I think with given time, I have to restrict myself to some nice examples. If you want to have more examples of ours and our partners, please visit trustedcomputing.eu. It is not the webpage of the Trusted Computing Group, but still a nice resource of demonstrations and a way to contact us. Thank you. Any questions? Everybody happy?
So, what's the state of deployment of TPMs to non-trusted controllers?
So, what's the state to the deployment of TPMs in controls? That is a tricky question. We're working together with companies like evaluating how we can use TPMs in their routers. We are involved in a German-funded national project on that. We have a lot of experience on implementing, including TPMs within ARM architectures or Atom architectures and this thing. We can do that. We're working together with, for example, one company in Germany building a VPN gateway, a VPN box that uses TPM exactly for protection of credentials. There are also other examples of vendors that are using the TPM in broadly used devices like ATM or gambling machines. That is already state of the art. Exactly in the data environment, I am not aware that it is already used, but I guess that there will be a quite steep adoption curve because it is a good use case for using the technology. Compared, for example, to typical PCs and their complexity in the software outfit there. Anything else? Okay, thank you.
Thank you, Nicolai.
That's downstairs?
Yeah, downstairs. When you're looking at the registration desk, it's to your left.
Oh.
There is a break now until 4:15.
Yeah.